All right, in this video, we're going to go over the study guide for the final exam, and there are going to be two videos for this. The first part would be problems 1 through 15, and then part 2 would be problems 16 through 30, okay? So what you'll see here is similar to what will be on the actual final exam for my college algebra sections, and also you will be allowed to have a one sheet of notes with writing on the front and on the back, okay? And also make sure that you do bring your own graphing calculator and your own one sheet of notes and something to write with. So now we'll get started with the study guide. In problem number 1, I'm going to solve the equation x minus 3 divided by 3 plus x plus 5 divided by 2 is equal to 19 divided by 6. All right, in this case here, and since the space is kind of limited, let me go ahead and write the equation up here. All right, in this case here, now notice that the denominators are different. So what I need to do here is find an LCD, or the least common denominator, for 3, 2, and 6. That's going to be the smallest number that's divisible by 3 and by 2 and by 6. In this case, it's going to be 6. So the LCD of 3, 2, and 6 will be 6. And what I'm going to do here is multiply each and every term in this equation by that LCD of 6. So it'll be 6 times x minus 3 over 3 plus, and then 6 times x plus 5 divided by 2. And that's equal to, and I'll put 19 over 6 in parentheses. That's going to be multiplied by 6. All right, so now let's simplify this. If I divide 3 into 6 for this term, that's going to go 2 times. So I'm going to have 2 times the quantity x minus 3 plus, and if I divide 2 into 6, that's going to go 3 times. So I will have 3 times the quantity x plus 5, and that's equal to 19 over 6 divided by 6, 19 over 6 times 6, I'm sorry. The 6 is divided out, I'll be left with 19. So I have the equation 2 times the quantity x minus 3 plus 3 times the quantity x plus 5 is equal to 19. Now let's remove the parentheses and combine some like terms here. If I do 2 times x, that's going to be 2x. Minus 2 times 3 will be 6. And then plus 3 times x will be a plus 3x. And the plus 3 times a plus 5 will be plus 15. And that will be equal to 19. Now let's combine some like terms here. 2x plus 3x is 5x. Minus 6 plus 15 would be a plus 9. And that's equal to 19. So I have 5x plus 9 is equal to 19. Now I need to get 5x by itself. I'm adding 9, so I need to subtract 9 on both sides. So this means 5x is equal to 10. And to get x by itself, I'm multiplying it by 5, so I divide both sides of the equation by 5 to get x is equal to 2. Now notice I didn't mention anything about checking, but if you have the time, you can check this solution. But I will tell you that x equals 2 is the solution to that linear equation. Okay. All right, that's problem number 1. Problem number 2 is solving the quadratic formula. And you have to know what the quadratic formula is. So here, the quadratic equation that we're dealing with is x squared minus 2x plus 17 is equal to 0. So first of all, I need to identify what A, B, and C are. So in this case, A comes from the coefficient of the x squared term. In this case, the A is going to be 1. The B is the coefficient of x, that's -2. Your C is your constant term, that's 17. So in this case here, your quadratic formula, if you recall, will be x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So here you're going to substitute the a, the b, and the c in that quadratic formula and simplify. Okay, so you get x is equal to the negative sign. I bring that down. That b is -2, so it'll be negative of -2 plus or minus the square root of b again is -2, that's squared, minus 4 times a, which is 1, times c, which is 17. That whole thing is divided by 2 times a, which is 1. All right, next we simplify here. Negative of a -2 would just be plain 2, plus or minus the square root of. -2 squared is -2 times -2. That's going to be 4, minus 4 times 1, which is 4. And then 4 times 17 will be 64. All that's divided by 2 times 1, which is 2. Now, if I simplify what's underneath that radical, 4 minus 64, I'm sorry, this should be 68. Okay. Okay, I had 64, that should be 68. And that's 4 times 1, that's 4 times 17 is 68. So now, 4 minus 68 will be -64. So here I'm going to have 2 plus or minus the square root of -64, and the whole thing is divided by 2. Okay. So now, the square root of -64. Well, the square root of 64 is 8, but that negative means that there's -1. So the square root of -1 will be I. So the square root of -64 will be 8i. So this will be 2 plus or minus 8i. Whole thing is divided by 2. Now, if I break this up, this will be 2 divided by 2 plus or minus 8i divided by 2. 2 divided by 2 will be 1, plus or minus 8i divided by 2 will be 4i. So here, the two solutions are 1 plus or minus 4i. This means 1 plus 4i and 1 minus 4i. And you can leave that answer as is, like that. Okay. Number 3 is solving the equation by factoring. So here we've got x cubed minus 14x squared plus 48x equal to 0. And he'll want to solve that equation by factoring. All right, so I'll go ahead and rewrite that equation. X cubed minus 14x squared plus 48x equal to 0. All right, now I need a common factor that's in x cubed and minus 14x squared and plus 48x. Well, obviously, there's an x involved. I have to take the common variable with the smallest exponent, so it'll be x to the 1. And then to get what's inside the parentheses, I divide each of these terms by that common factor of x. So x cubed divided by x will be x squared, minus 14x squared divided by x will be 14x, plus 48x divided by x is 48. And that's equal to 0. Now inside I have x squared minus 14x plus 48. I can factor that into 2 binomials. So I'll bring this x down and write this as a product of two binomials. That x squared, I can break that up as x times x, and I'll need factors of 48 that would give me negative 14x as a middle term. And it will have to be minus 6 and minus 8. Because the middle term is plus a minus and the last term is a plus. So both the 6 and the 8 must be minus. Okay. Now, factor completely, I have x times x minus 6 times x minus 8 equal to 0. Now I'm going to set each individual factor equal to 0. So I will set this x to be equal to 0. And then, or x minus 6 equal to 0, or x minus 8 equal to 0. And each equation I'm going to solve for x. Well, x equals 0 is already solved for x. Now for the x minus 6 is equal to 0. If I add 6 to both sides, I will get x is equal to 6. And then for the x minus 8 equal to 0, if I add 8, that would mean x is equal to 8. So my three solutions for this polynomial equation will be x equals 0, x equals 6, and x is equal to 8. Okay. All right, onward to problem number 4. We have a radical equation. Here we're going to solve this equation. The square root of 5x plus 14 equal to x. Now this is the one where you have to check your proposed solution for that equation. Okay, so if I had the square root of 5x plus 14 equal to x, and notice that the square root symbol is already by itself. So to get rid of that square root, the opposite of taking the square root would be to square both sides of this equation. So that's what I'm going to do here. Take the square of both sides of this equation. So in this case here, when I square both sides on the left side, the radical will be gone when I square it. So I'll be left with what's underneath it, 5x plus 14. And that's equal to x in u squared will be x squared. So now I have a quadratic equation. And in a quadratic equation, when I solve it, I need to move all the terms on one side of the equation to get a 0 on the other side. So I need to move the 5x and the plus 14 over to the opposite side. And I'll do that by subtracting 5x on both sides. And also I'm going to subtract 14 on both sides of that equation. So that means I have 0 is equal to x squared minus 5x minus 14. That's going to be equal to 0. Now notice I have a quadratic equation. I can factor that into two binomials on this side. So here that x squared, I break that up as x and x. Now I need factors of a minus 14 that will give me negative 5x as a middle term. And they'll have to be 7 and 2. But since that middle term is a minus, the larger of the two factors has to take the sign of the middle term. So that 7 has to be minus and the 2 has to be plus. So I have x minus 7 times x plus 2 is equal to 0. And then we'll set each binomial factor equal to 0 and solve the x. So this means x minus 7 is equal to 0, or x plus 2 is equal to 0. Each equation will solve for x. So for the x minus 7 equal to 0, if I add 7, I'll get x is equal to 7. Or for the x plus 2 is equal to 0, if I subtract 2, that means x is equal to negative 2. So these are my proposed solutions, but only one of them satisfies the original equation. And to find out which one, this is where you have to check your proposed solution. So here I'm going to do the check, and I'll start with x is equal to 7. Using the original equation, I'm going to replace each x with the 7. So here I'm going to have the square root of 5 times x, which is 7, plus 14, equal to x. That's going to be replaced with 7. And then simplify what's underneath that radical. 5 times 7, that will be 35. So that's the square root of 35 plus 14 equal to 7. And then 35 plus 14 will be 49. So the square root of 49 equals 7. Square root of 49 does equal to 7. So here I have a true statement. So that means x equals 7 pretty much is going to be the solution for that radical equation. And if you want to, you can go ahead and check that x is equal to -2 to verify that it's not going to be a solution. Because if we do the square root of 5 times -2 plus 14, that should equal to x, which is -2. Here, again, substituting the x with -2 this time. So here you have the square root of 5 times -2, that's -10, plus 14, that should equal to -2. 10 plus -10 plus 14 will be 4. So if I take the square root of 4, I'm going to get 2. 2 does not equal -2, as you can see. So this is considered to be an extraneous solution. So x equal -2, I can cross that out and conclude that x is equal to 7 is the solution to that radical equation. All right, so that's problem number 4. All right, number 5 is to solve the system. I mean, not the system, solve the equation, which is an absolute value equation, by the way. There's 3 times the absolute value of 2x minus 5 plus 4 is equal to 25. All right, so in this case here, I would need to get the absolute value by itself. That means I need to move the 4 over to the opposite side and get rid of the 3 that's in front. So to move the 4 over, I'm adding 4. I need to subtract 4 on both sides. So I have 3 times the absolute value of 2x minus 5 equals 25 minus 4. That's 21. And then to get the absolute value of 2x minus 5 by itself, it's being multiplied by 3, so I need to divide both sides of this equation by 3. So here I have the absolute value of 2x minus 5 is equal to 7. And now I have an absolute value symbol by itself, so I can write that as 2 equations. One of them will be 2x minus 5 is equal to 7. Or the second equation will be 2x minus 5 equal -7. And each equation I'm going to solve for x. So for the 2x minus 5 is equal to 7. If I add 5 to both sides, that would mean 2x is equal to 12. Then divide both sides by 2 to get x by itself. That means x is equal to 6. And then for the second equation, 2x minus 5 equal -7. Again, add 5 to both sides. That will mean 2x is equal to, this time, -2. And then to get x by itself, I'll divide both sides by 2. That means x is equal to -1. So my 2 solutions for this absolute value equation will be x is equal to 6 or x is equal to -1. Okay. All right, problem number 6. Here we have an inequality that we need to solve. Here we got 7 times the quantity x minus 8 plus 3 is less than 6 times the quantity x minus 5, and then plus 3x. Well, we need to remove parentheses and combine some like terms on each side of this inequality. So If I start on the left side, let's distribute the 7 over the x minus 8. When I do that, I'll have 7 times x, that's 7x, minus 7 times 8, that's 56. Then bring down that plus 3 is less than 6 times x, that's 6x, minus 6 times 5, which is 30, plus 3x. All right, next we'll combine like terms here. Let's bring the 7x down. And I'm going to do negative 56 plus 3. That would be negative 53. That'd be less than, let's see, 6x plus 3x is 9x, minus 30. Now, when you solve an inequality with variables on both sides, the best advice would be to get the variable on the left-hand side. So I'm going to move the 9x over to where the 7x is by subtracting 9x on both sides. When I do that, 7x minus 9x will be negative 2x minus 53 is less than negative 30. And then to get that negative 2x by itself, I'm subtracting 53. So I need to add 53 to both sides. So that means I have negative 2x is less than, let's see, negative 30 plus 53 will be 23. Yep, just 23, plain 23. Then I'm going to divide both sides of the inequality by negative 2. But when I do that, what's going to happen here is that this inequality symbol of less than will change to greater than. And I'm going to leave this as, let's say, negative 23 over 2. So x is greater than negative 23 over 2 will be the solution set for that inequality. And keep in mind, anytime you multiply or divide both sides of an inequality by a negative, your inequality symbol switches over to the opposite direction. All right, so that's problem number 6. All right, number 7 is an absolute value inequality. Here we got the absolute value of 2x plus 13 is greater than 7. Now, here we got greater than, so that means I need to write this as 2 separate inequalities. 2 separate inequalities. The first inequality will be 2x plus 13 is greater than 7, or 2x plus 13. Here we switch this inequality from greater than to less than, change the sign from positive 7 to negative 7. So with greater than or equal to in an absolute value inequality, you have to write it as 2 separate inequalities. Now for each inequality, we're going to get x by itself. So for the 2x plus 13 is greater than 7. I subtract 13 on both sides. That will mean 2x is greater than negative 6. And then divide both sides by 2. You'll get x is greater than negative 3. And as you can see here, I divided both sides of an inequality by a positive number. So that means that inequality symbol remains the same. And then for the 2x plus 13 is less than negative 7. If I subtract 13 on both sides to get the 2x by itself, that means I have 2x is less than negative 7 minus 13 would be negative 20. And then divide both sides by 2. That will mean x is less than negative 10. So the solution set would be x is greater than negative 3 or x is less than negative 10. So that's how we solve that absolute value inequality. All right, problem number 8, you're going to select the graph of a relation which is not a function, is not one-to-one, and is one-to-one. All right, let's select the one that is not a function. For it to not be a function, you cannot have an x value go into 2 different y values. So you have to choose the appropriate mapping that you see here that would not be a function, where you have an x value go into 2 different y values. And by looking at that, it will have to be mapping B. So this one is not a function. And for not one-to-one is this. You can't have a y value with 2 different x values. So it's either A or C, where it's not one-to-one. Here it's going to be C, because you see 3 is with -4 and -1. So this mapping C is not 1-to-1, which will mean mapping A is 1-to-1. And that's because only one y value is with only one x value. And not only that, by the way, it is also a function, because you only got one x to one y in each case. Okay, problem number 9 is to evaluate a piecewise function. And in this case, we got f of x is equal to, we only use the 3x plus 9 if your x value is less than 1, or use x squared plus 1 if your x value is greater than or equal to 1. And this will be for x is equal to 5. Well, since x is equal to 5, here I can see that 5 is greater than or equal to 1, so I need to use the x squared plus 1. So f of 5 would be this. I use x squared plus 1 by substituting the x with 5. So it'd be 5 squared plus 1. Square the 5, which is 5 times 5, that's going to be 25. And 25 plus 1 would be 26. So the value of this piecewise function when x is equal to 5 will be 26. Okay, f of 5 is going to be 26. All right, problem number 10 is to find the domain of the function f of x is equal to 18x squared plus 123x minus 203, all divided by x squared plus 5x minus 24. In this case here, I have a rational function. I have a numerator and a denominator. And in a rational function, you want to find out what values of x that would give you a 0 in the denominator. So we're going to take our denominator, which is in this case x squared plus 5x minus 24, set that equal to 0. So here we got a quadratic equation. So in this case here, I'm going to factor the x squared plus 5x minus 24. And I'm going to find out what the two factors are. So here, bring down the x and the x, because x squared is what that would give me when I multiply x times x. Now I need to find out what factors of -24 that would give me a positive 5x as a middle term. Well, I know 8 times 3 gives me 24. But here, the middle term is a plus, so the larger of the two has to take the sign of that middle term. So that 8 has to be plus, the 3 must be minus. So we got x plus 8 times x minus 3 is equal to 0. Now we're going to set each binomial factor equal to 0. So I'm going to have x plus 8 equal to 0, or x minus 3 equal to 0. And then we're going to solve each equation for x. So for the x plus 8 equal to 0, if I subtract 8, that would mean x is equal to -8. Or for the x minus 3 equal to 0, if I add 3, I'm going to get x is equal to 3. So these are the values of x that will give me a 0 in the denominator. x equal -8 and x is equal to 3. All right, now I'm going to write the domain in interval notation. And if you want to, you can draw a number line so that way you'll get an idea of how to write the interval notation for the domain. Let's say -8 is to the left of 0, 3 is to the right of 0. So we know at -8 and 3, we're going to get zeros in the denominator. So I'm going to use parentheses around -8 and parentheses around the 3. Now, any x value less than -8 will satisfy that rational function. Any x value in between -8 and 3 will satisfy that rational function. And any x value greater than 3 will satisfy that rational function. So if I go from left to right on this number line, the domain of this rational function would be this, from left to right, -infinity up to -8, or from -8 to 3, or from 3 on out to infinity. Okay. All right, so that's how we do problem number 10, find the domain of that rational function. You just set your denominator to be equal to 0, and then find out what x values will give you zeros in the denominator. All right, problem number 11 is the transformation of functions here. So here we're given the graph of f of x, which is the one on the left. And then we're going to make a graph of f of x plus 5 minus 3. Okay, so in this case here, notice I have a plus 5 here. That tells me I have a vertical, not vertical shift, a horizontal shift, because the plus 5 is next to the x. And then that minus 3 tells me I have a vertical shift. And of course, the horizontal shift, it says a plus 5. Anything horizontal means you have to do the opposite. Since it says plus 5, the opposite of adding 5 would have to be to subtract 5. And then for the vertical shift, we do exactly what it says. Subtract 3. Okay. So I'm going to go ahead and draw a table. I apologize for not putting any space here for that table. So in this case here, my ordered pairs are going to be, in this case, let's see if I can read this off. I'm going to use 4, 7. The other one, I'm going to do 7, 2. And the other one will be 10, 5. So first of all, according to the sequence of transformations, we must do the horizontal shift first, and then the vertical shift is always going to be done last. So for the horizontal shift, I'm going to come up with ordered pairs. That means I need to subtract 5 from each x coordinate, since it's a horizontal shift. That means your x values will change. So in this case here, if I do if I do 4 minus a -5, that's -1. Then bring the 7 over. For the 7, 2, if I do 7 minus 5, that will be 2. Bring the 2 over. And then for 10, 5, if I do 10 minus 5, that will be 5. Bring that 5 over. These are the ordered pairs after doing the horizontal shift. I finally have to do the vertical shift. I have to come up with ordered pairs for that. And whatever ordered pairs I get in this final column will be the ordered pairs for g of x. Now for the vertical shift, I have to subtract 3 from each y coordinate. So let me go ahead and bring over my x coordinates. So here for that first order pair, if I do 7 minus 3, that will be 4. And then for the next one, if I do 2 minus 3, that's going to be -1. And then the last order pair, 5, 5. If I do 5 minus 3, that will be 2. So these are my ordered pairs for g of x. And I will plot those on the coordinate plane. So in this case here, we start with -1, 4. So that means I go to the left 1 and up 1, 2, 3, 4. That would be that point. And then for 2, -1 would be to the right 2 and down 1. Then finally for 5, 2 would be to the right 5 and up 2. And if I connect those points, you'll see the graph is similar to the one for y for f of x, but it's just shifted to the left 5 and down 3. To the left 5 and down 3. Okay. So that's what problem number 11 is. Be sure that you are familiar with those transformations of functions back in section 2.5. All right, number 12. Here we got for the functions f of x equal 3x minus 1 and g of x equal -7x plus 2. We want to find f minus g of x. Now, f minus g of x means this. F of x minus g of x. F of x minus g of x. And in this case, your f of x is at 3x minus 1. Minus, now for the g of x, that's -7x plus 2. But notice I'm putting -7x plus 2 in parentheses. And that's because I'm subtracting the entire g of x function from f of x. Okay. And now the next step I'm going to do here is simplify this. Distribute that negative over the -7x plus 2. This minus will make -7x plus 7x. The minus sign makes a plus 2 or minus 2. And if I combine like terms, 3x plus 7x will be 10x. Minus 1 and a minus 2 will be minus 3. So the difference of the two functions, f and g of x, will be 10x minus 30. And that's as far as you go with that problem. Okay. So that right there is problem number 12. Problem number 13 is the composition of two functions, f and g. Here you got f of x equal to 2x plus 5 and g of x equaling to x squared minus 7. And here I want to find the composition of f with g of x. Okay? Or we can say f circle g of x, which means f of g of x. So now your g of x is going to be your inside function. And g of x is equal to x squared minus 7. So I'm going to bring down the f and replace that g of x with x squared minus 7. So I'm going to be evaluating f of x squared minus 7. But of course, f of x is equal to 2x plus 5, which means for every x in the f of x function, I'm going to replace it with what g of x is. And here g of x is that x squared minus 7. So for this x in the f of x, I'm going to replace it with g of x, which is x squared minus 7. And in the 2x plus 5, that x will be replaced with what g of x is, x squared minus 7. And then I'm going to simplify the right-hand side. Distribute the 2 of the x squared minus 7 2 times x squared would be 2x squared minus 2 times 7, which is 14, and then I bring down that plus 5. Well, negative 14 plus 5 would be a minus 9, so I end up with 2x minus 9. So that means that the composition of f with g of x will end up being 2x squared minus 9. Okay. All right, so that's problem number 13. All right, problem number 14 is to determine the functions f of x and g of x such that the composition of f with g of x is equal to 5 divided by x squared minus 3x plus 6. That quantity is to the 6th power. And I'll go ahead and rewrite this. So here I'm going to be decomposing the two functions. Well, decomposing this composite function and write it as two functions, f of x and g of x. Now notice that g of x is always your inside function in this case. So the inside function here will have to be something like, let's say, this denominator of x squared minus 3x plus 6, and that quantity is to the 5th power. Now to find out what f of x is, if I'm using this as g of x, that would mean that this was put in place of x in the f of x function, which means that f of x had to start off as 5 divided by x. So that means f of x was 5 over x, and g of x will have to be the quantity x squared minus 3x plus 6 raised to the 5th. Now another way you could decompose that would be something like this. I'm going to write f of x here and g of x. Notice what's inside the parentheses, that x squared minus 3x plus 6. I can let that be g of x. And if this expression was put in place of x in the f of x function, that means that the f of x had to begin as 5 divided by x raised to the, and this should be to the 6th power. This also should be to the 6th power as well. So f of x is 5x to the 6th. G of x is equal to x squared minus 3x plus 6. Or you could write it like this and let the whole thing be g of x, which will mean f of x has to be 5 over x. Okay, so that's problem number 14. Number 15 is a function f of x equal to 2x minus 6, and we want to find the inverse of that function. Well, there's a 4-step procedure for finding the inverse of any function. And that is, we first take that function, that f of x expression, change it to y. F of x notation would be y. So it'd be y equal to 2x minus 6. Replace f of x with y. That's the first step. The second step would be to interchange x and y. That means that the y will be your x, and your x will be y. So it'll be x is equal to 2y minus 6. And then the next step would be to solve the equation for y. So I need to get y by itself. I'm subtracting 6. I need to add 6 to both sides. So that means I have x plus 6 is equal to 2y. And then to solve for y is being multiplied by 2, so I need to divide both sides by 2. So that means y is equal to x plus 6 all over 2. Then the final step would be to replace that y with f inverse of x. So f inverse of x would be equal to this expression right here. X plus 6, whole thing divided by 2. Okay, so that's problem number 15. And that's going to be part 1 of the review sheet for the final exam. Be on the lookout for part 2, which will cover the remaining 15 problems. That's problems 16 through 30.